discuss exponential functions. And first of all, we'll talk about exponents and properties, okay? So you guys know if you have a to the power m over n, right? So this is same as nth root of a raised to the power what? M, right? If a is a real number, then a to the power m over n is same as nth root of a raised to the power m. So now here a is a real number and m and n are integers. So you know that, right? Because this is, look here, this is a to the power m over n. It's same as a to the power 1 over n raised to the power m. Is that right? So a to the power 1 over n is same as what? Nth root of a. So this is nth root of a raised to the power m. So the next one, look here. So if you want to evaluate 16 raised to the power 3 over 4, so how do you evaluate this? So this is same as what? So if you use this is same as 4th root of 16 raised to the power 3, right? So what is 4th root of 16? So 4th root of 16 is 2. So this is 2 to the power 3, which is equal to what? 8, right? 2 to the power 3 equal to 8. Okay. So similarly, you see you can figure out, let's say, 27 raised to the power negative 1 over 3. So what is 27 raised to the power negative 1 over 3? So remember the law of exponents, right? If you have a to the power negative m, it is same as 1 over a to the power m. So 27 raised to the power negative 1 over 3 is same as 1 over 27 raised to the power 1 over 3, right? And this, if you know, if you have a to the power 1 over n, so this is same as what? Nth root of a, right? So now it's going to be 1 over cube root of 27, right? And what is cube root of 27? What is this? This is 3. Is that right? So this is 1 over 3. Are you with me, guys? So if you want to graph the function, let's say fx equal to 2 to the power x, graph fx equal to 2 to the power x. So let's say if you make a table, if you plug in x equal to 0, so what is the value of f of 0? You plug in x equal to 0. So what would be f of 0? If you plug in x equal to 0, f of 0 will be what? 2 to the power 0. That is equal to what? 1. Right? If you plug in x equal to 1, so what is f of 1? So this is 2 to the power 1 equal to what? 2. Did you see that? If you plug in x equal to 2, so it will be f of 2 equal to 2 square, which is what? 4. So if you plug in x equal to 3, so 2 to the power 3, this equal to what? 8. You see that? Now if you plug in -1, what is this? So what is f of -1? 2 to the power -1, right? So what is 2 to the power -1? 1 over 2. 1 over 2 to the power 1, right? Which is 1 over 2. So 1 over 2 is what? 0.5. So this is 0.5. So similarly, if you plug in x equal to -2, so f of -2 equals to 2 to the power what? -2. So 2 to the power -2 is 1 over 2 to the power 2 equals to 1 over 4 equals to what? 0.25. So this is 0.25. Right? Are you with me? And then if you plug in -3, so 2 to the power -3, which is 1 over 2 to the power 3. So what is, this is 2 to the power 3 is 8. So what is 1 over 8? 0.1, right? 125, is that right? This is 0.125. So now, are you with me? So now you plot these points on the graph, you see. So if you consider your integer as your domain, so you'll have this type of graph. Let me show you here, okay? So this is your x-axis. This is your y-axis. And let's say this is 2, 4, 8. And this is 1, 2, 3, 4. Sorry. This is 6. Sorry. And this is, let's say this is 6. And this is 8. And here is 7. And similarly, you can do that. This is 2, 3, 4. And here you have -2, -4, -6, something like that. Okay? So now you plot the point -3, 0.125. So -3 is right here. This is -3. You see? This is -1. So -3, 0.125. So it's going to be pretty close to x-axis, this point. And then you have a -2, 0.25. So -2, 0.25, it's pretty close to here. And then -1, 0.5, somewhere here. 0, 1, right? You see 0, 1, and you have a 1, 2. So this is your 1, 2, this point. And then you have a 2, 4. So 2, 4, this point. And you have a 3, 8. So 3, 8, you have this point. So now you see, if you want to consider integer as domain, so you have a graph like this. Right? So if you consider real numbers as a domain, if you consider all real numbers as domain, then your graph looks like this is your x-axis, this is your y-axis. You see you have something like this, right? Something like this, so you'll have a graph like what? this. So this is the graph of the function f(x) equal to what? 2 to the power x. 2 to the power x. Right? So what is the domain here? Real numbers. So the domain is negative infinity, comma infinity. What is the range? Range is, you see the range, the graph is above the x-axis, right? So what is the range here? 0, comma positive infinity. And this x-axis, the graph do not intersect x-axis. So the x-axis is the horizontal asymptote. So x-axis is the horizontal asymptote. X-axis is the horizontal asymptote. So, yeah. Now you see this is an example of exponential function. Okay, so we define exponential function. Let me show you here. So this is, we did that one, right? So this is the definition for exponential function. So if you have a positive and a is not equal to 1, a is positive and a is not equal to 1, then f(x) equal to a to the power x is the exponential function with the base a. f(x) equal to a to the power x is the exponential function with base a. So this is an exponential function. Did you get it? Right? So now this is f(x) equal to 2 to the power x. So this is an exponential function where base a equal to 2. Did you get it? Right? If you have f(x) equal to, let's say, 1/2 to the power x, so this is also an exponential function with a equal to 1/2. Right? So this is the graph of exponential function. Make sense? Good. So there are some properties for the exponential function. So, so let me write down the properties of exponents. Properties of exponents. For any real number a positive and a is not equal to 1, for any real number a positive and a is not equal to 1. For any real number a positive and a is not equal to 1, so if you have a to the power b equal to a to the power c, so this is equivalent, or this is if and only if, okay, if and only if b equal to c. Okay, and then If you have a 0 is less than a is less than 1 and m is less than n, then what will happen? Then you will have a to the power m is greater than what? A to the power n. So these are the important properties of exponents. Okay? Did you get it, guys? And then if you have a, so this is property 1, this is property 2, property 3. If a is greater than 1, right, then what will happen? If a is great, let's say, if a is greater than 1 and m is less than n, if a is greater than 1 and m is less than n, then a to the power m is less than what? A to the power n. Did you get it? Okay, I think we did that, right? And if you look here, the graph of the function f(x) equal to 2 to the power x. So this is continuous and increasing, right, throughout the domain, right? So the graph of this function is continuous on increasing and continuous on entire domain, okay? This graph, I'm talking about this graph, okay? The graph of f(x) equal to 2 to the power x. So this is continuous and increasing, continuous and increasing over the entire domain, okay, on its entire domain. Okay. And I told you the x-axis is the horizontal asymptote because the graph does not intersect x-axis. Okay? Good. So now the thing is, if you have a value of a between 0 and 1, so let's say if the value of a is between 0 and 1, if 0 is less than a is less than 1, and you have f(x) equal to a to the power x, in this case, the graph will be decreasing and continuous on its entire domain. So you can simply take, let's say you want to pick a equals to, let's say, 1/2, okay? If that is the case, right? If you have a equal to 1/2, your function will be 1/2 to the power x. So this is your exponential function. And I want to make a table for that, okay? So you see when you plug in x equal to 0, right? If you plug in x equal to 0, so 1/2 to the power 0 is 1. You know that, right? If you plug in x equal to 1, so this is 1/2, which is 0.5. Is that right? Right? If you plug in x equal to 2, so this would be 1 over 4, which is 0.25. See that? And then if you plug in x equal to 3, so this is 1 over 8. Are you with me, guys? You see, if you plug in x equal to 3, so f3 is going to be 1/2 raised to the power 3, right? So 1/2 raised to the power 3 is 1 over what? 8. So that's what I'm talking about. Did you see that? And I think like 1 over 8 is that 0.125? Right? Yeah, 0.125. So now if you plug in -1, so what is f of -1? So f of -1, you plug in x equal to -1 here. So this will be half to the power what? -1. Okay? So half to the power -1, this f of -1 is 1 over, so this is same as 1 over 2 to the power -1. Right? So this is same as what? 2. Because remember, if you have a to the power -n is same as 1 over a to the power n, or a to the power n is same as what? 1 over a to the power -n. So if you have 1 over a to the power -n, it will be what? A to the power n. So you have 1 over 2 to the power -1, which is 2 to the power 1, which is what? 2. See that? And then if you plug in x equal to -2, f of -2, so you have a half raised to the power -2, right? So what is that is? This is same as f of -2 is same as what? 1 over 2 to the power -2, right? So this is, when you bring it up, it will be 2 to the power 2, right? So that will be what? 4. If you have a -2, it will be what? 4. If you have a -3, if you plug in there, it will be at 8. Make sense? So now if you plot these points, okay? So -3, 8. So let's say this is your -3, 8, right? So let me, this is 1, 2, 3, 4, 5, 6, 7, 8. So -1, -2, -3, +1, +2, +3. Okay? So -3, 8. So -3 is here, and 8 is, you see the -3, 8. So it's going to be here. So this is -3, 8. And then you have a -2, 4. So -2, 4. So -2, 1, 2, 3, 4 right here. So this is -2, 4. And then you have a -1, 2. So -1, 2 right here. Are you with me, guys? And then you have a 0, 1. 0, 1 is right here. Then you have a 1, 0.5. 0.5. 1, 0.5 is here. 2, 0.25 is here. 3, 0.125 is here. So if you join this graph like this, you see, you'll have a graph like this. Did you see that? The blue one is the graph of the function f(x) equal to half raised to the power x. So this is decreasing, right? So the graph is decreasing and continues on its entire domain. And you guys know that the domain is -infinity, +infinity. So the domain is -infinity, +infinity. And the range is also, I'm talking about the blue one, okay? For this one, for the graph f(x) equal to half raised to the power x. So the domain is -infinity, +infinity. Range is 0, infinity. And, x-axis, or you can say y equal to 0, is the horizontal asymptote, is the horizontal asymptote. So the x-axis, which is y equal to 0, is the horizontal asymptote, and the function is continuous and decreasing on its entire domain. Okay? So f(x) equal to half to the power x is decreasing, right? You see that? Decreasing. And continuous, decreasing and continuous on its entire domain. Make sense? Okay, we did it, right? So now if you have a, remember that guys, if you have a fx equal to, let's say, 2 to the power negative x, so you see if your graph is fx equal to 2 to the power x, remember y equal to negative fx, right, is the reflection of y equal to fx across x-axis. You know that, right? So if you want to reflect, let's say if you have a f of negative x, first let me tell you this, okay? Let me write down this here, okay? The graph of y equal to f of negative x is the reflection. Is the reflection of y equal to fx, reflection of the graph of y equal to fx across y-axis. You know that, right? The graph of y equal to f of negative x is the reflection of the graph of y equal to fx across y-axis. So, if this is the case, now look here, your fx is 2 to the power x, your fx is 2 to the power x, and you guys know that f of negative x is 2 to the power negative x, right? So this 2 to the power negative x is same as what? 1 over 2 to the power x. And this is same as f of negative x equal to 1/2 to the power x. You see that? So the graph of 1/2 to the power x is the reflection of fx equal to 2 to the power x across the y-axis. Is that right? So you see in the graph, the blue one is the graph of the function fx equal to 1/2 raised to the power x. The black one is the graph of the function fx equal to 2 to the power x. Right? So this is graph of this black one is the graph of fx equal to 2 to the power x, and the blue one is the graph of fx equal to 1/2 to the power x. So the blue one is the reflection of black one, right? The blue graph is the reflection of black graph across y-axis, right? You see, this graph is reflected here, and you got this graph. Make sense? Okay. Okay, so now I think like you can do this one. And remember that if you know the graph of fx equal to 2 to the power x, so this fx equal to 2 to the power x, so how do you graph? So you graph fx equals to negative 2 to the power x. So you need to graph fx equal to negative 2 to the power x. So remember that the graph of y equal to negative fx, let me write down here, negative fx, okay, is the reflection of graph of y equal to fx across x-axis. not this. The graph of y equal to negative fx is the reflection of the graph of y equal to fx across x-axis. So now you see this is the graph of the function fx equal to 2 to the power x, the black one, right? If you reflect that across x-axis, so you'll have a graph like this, guys. So you reflect this, the graph of fx equal to 2 to the power x across x-axis. So you'll have a, right? Yeah. So the red one is the graph of the function fx equal to negative 2 to the power x. See that? Right? If you reflect the black one across x-axis, you have this. Yeah. Okay. So I think you can do this thing now. So now, how do you solve this exponential equation, guys? Solve 1 over 3 raised to the power x equals to what? 81. How do you solve this? Do you have any idea? So remember, if a to the power b equal to a to the power c, so this is the property of exponents, right? If a to the power b equal to a to the power c, so this is equivalent if and only if b equal to c, right? If you have this is base are equal, then you can equate the exponents, right? So now you have to make the same base here. So this 1 over 3 is same as 3 to the power negative 1 raised to the power x equals to 81. I'm trying to make the same base on both sides and apply this. Okay? So this 3 to the power negative 1 to the power x is same as 3 to the power what? Negative x. And then this 81 is same as 3 raised to the power what? Number equal to 81. 3 to the power? 3 to the power 1 is 3. 3 to the power 2 is 9, right? 3 to the power 3 is 27. So 3 to the power 4 is what? 81. That makes sense? So now you can apply this. If a to the power b equal to a to the power c, then you can write b equal to c. So if 3 to the power negative x equal to 3 to the power 4, then you can write negative x equal to 4. And which is same as x equal to what? Negative 4. So this is the value of x. Did you get it? Okay. So the solution set of this equation is what? Negative 4, right? Negative 4. Now how do you solve this equation? So if you want to solve, let's say 2 to the power x minus 4 equals to 8 to the power x minus 6. So how do you solve this equation? You try to make the common base on both sides. Okay, we want to use this one. Okay. So you have to make the common base. So here you have a base 2, right? So can you make the base 2 here? Yes. What is 8? 8 is 2 to the power. 2 to the power, what number is 8? 3, right? 2 to the power 3 and raised to the power what? X minus 6. And so this will be 2 to the power x minus 4 equals to 2 to the power, you know the power is raised by power and you multiply them, right? So you have a 3x minus 18. And then you have the same base, so you just equate the exponents. X minus 4 equal to what? 3x minus 18, right? And then, so you add 4 on both sides. Let's cancel that. And so x equal to what? 3x minus 18. Actually, you can, no, 3x minus, hold on a second, okay. It's the same thing. So what is negative 18 plus 4? It's negative 14, right? Right? And so you subtract 3x from both sides. You cross them out. So what is x minus 3x? Negative 2x. So negative 2x equal to what? Negative 14. So negative 2x equal to negative 14. So you divide both sides by negative 2. You cross them out. So x equal to what? 7. So the solution to this equation, the solution side is what? 7. Good? Yes? Okay. What? 7 or 11? Did I make a mistake here? So this is 2 to the power x. Okay, that's right. Because x equal to 7. 2 to the power 3 is 8. Yeah. Right? But if you have a 2 to the power x plus 4, then you will get one different answer. That makes sense? Okay, so now how do you solve this one? You know how to solve this one, right? Let me do this one. So solve x to the power 4 over 3 equals to what? 81. So how do you solve this equation? So how do you do that, guys? Is that same as this? This is same as x to the power 1 over 3 raised to the power 4, right? Equals to 81. Same, right? Because x to the power 1 over 3 raised to the power 4. You multiply 4 and 1/3, you will get 4 over 3. So now it will be, so this is cube root of what? X to the power 1/3 is cube root of x raised to the power 4 equals to 81. Is that good? Does that make sense? So now, remember one thing, guys, the square root property, if you have x squared equal to k, so if x squared equal to k, then x equal to plus or minus radical k. You know that, right? You know that, right? But here, you got to be a little bit careful. You don't have x squared. So this is true if you have x at the even power. Let's say positive, positive even power or exponents, whatever. If you have x to the power 4 equal to k, then x equal to plus or minus 4th root of k. That makes sense? So this, you need to know this one. This. Okay? So now it looks like similar to this one. So now this is same as cube root of x equal to plus or minus, right? 4th root of 81. Good. So what is 4th root of 81? So this is cube root of x equal to plus or minus. What is 4th root of 81? Is that 3? 4th root of 81 is 3. Do you guys know that? So look here, I can do it like this also. 4th root of 81, right? And it's like, so this is 4th root. 81 is 3 raised to the power what? 4. Because 3 times 3 times 3 times 3 is what? 81, right? So this is same as 3 to the power 4 raised to the power what? 1 over 4. So now 3 to the power, if the power is raised by a power again, you multiply them, okay? So, and you see this is 4 times 1 over 4 is 1, so 3 to the power 1 is what? 3. That makes sense? You see that? So 4th root of 81 is what? 3. So now, so what do you have now? So now you have a cube root of x equal to, you take positive sign, you have a cube root of x equal to what? 3. And if you take negative sign, so what do you have? Cube root of x equal to what? Negative 3. Good? So now this is the cube root of x. So you cube on both sides, okay? Or raised to the power 3, whatever. Raised to the power 3. So that means cubing, okay? Cubing on both sides. Are you with me, guys? Right? So what is this? If you raise to the power 3, it should be x, right? And this is 3 to the power 3. What is 3 to the power 3? 27, right? So do the same thing here. Okay, you cube on both sides, cubing on both sides. Cubing on both sides. So we'll get x equal to negative 3 raised to the power 3. Right? So now, what is this, guys? X equal to negative 27. So the solution set is negative 27 comma positive 27. Yeah. Good? Yep. So plus or minus 27. Okay, I think you can do the rest of the problem. Now the compound interest, okay? Look, this is the compound interest formula, okay? This is the so if the P dollars are deposited in an account, so let's say you want to deposit P dollars, okay? So this is the deposit amount, or we call principal. Okay, and at annual rate of interest, the annual rate of interest R, okay? And this annual rate of interest are paid n times a year. Okay. Then after t years, then after t years, the amount A will be equals to P times 1 plus R over N raised to the power Tn. So this is the formula. This is the amount after t years. Okay. So where A is the amount after t years. That makes sense? So this is the formula for the, and you see the compounded, this is compounded n times a year. Okay, this is compounded n times a year. So A equals to P times 1 plus R over N raised to the power Tn. Okay. So look here. So suppose $1,000 is deposited in an account paying 4% interest rate per year, compounded quarterly. So compounded quarterly means the interest is paid, like 4 times a year. Compounded quarterly. Compounded semi-annually. So if you compound the amount like semi-annually, then it will be, I think, the paid 2 times a year, right? And then the next one is, if it is daily, the N will be what? 365, right? Because the compounded daily means, right, the value of N is 365. Compounded quarterly means N equal to 4. Daily means 365, okay? So let's use this formula, okay, to, so what is the value of P? $1,000. So because $1,000 is deposited, okay, so P is 1,000. So P is 1,000, right? Deposited in an account paying 4% interest. So the rate of interest is 4%. 4% means 0.04. Okay? And compounded quarterly. So you gotta be very careful here, okay? You compounded quarterly, right? So compounded quarterly, so that means N equal to 4. You compounded quarterly, so that means N equal to 4. And you have to find out the amount equal to what? After 10 years. So T equal to what? 10. After 10 years. So that means after T equal to 10. So you just plug in the formula. So you know the formula is A equal to P 1 plus R over N raised to the power Tn. So you have every information on the right side. You have the value of P, you know the value of R, you know the value of T, and you know the value of N. You plug in here. So A equals to, so this is 1,000, 1 plus R is 0.04 over N is, what is the value of N? 4 raised to the power T is 10, and times 4. Just use the calculator, okay, to evaluate this. So this is 1000. So this is 1 plus 0.04 divided by 4 is 0.01 raised to the power 40. 10 times 4 is 40, right? Make sense, guys? So, good. So A equal to, so this is 1000 or 10,000? 1000, yeah. This is 1000, okay? So 1000 times 1 plus 0.01 is 1.01 raised to the power 40. Yeah, just use calculator. So what is that? 1000 times 1.01 raised to the power 40. 1000 times 1.01 raised to the power 40. So I got 1488. So A equal to 1488. This is like 4. 1488.863734. So this is the amount after what? 10 years with no withdrawals. Okay? Does that make sense? So we find the amount after. Okay, so now if you round to the nearest cent, so it's going to be, what is the amount? It's going to be 1488.86. And in part B, you need to find out the interest. Okay? How much interest is earned over the 10-year period. So you need to find how much interest is earned over the 10-year period. Over the 10-year period. So that means, you know, the interest, this is I is the interest, is equal to amount after 10 years minus amount deposited, A minus B, right? So what is the amount? 148, so the interest, let's say this denoted by I, this is the interest. So 1488.86 minus P is, what is the P? 1000. So this is going to be $488.86. This is the interest. $488.86. Make sense? Okay? We got it, right? Okay. I think the second one is, if you look, the second problem. So Becky must pay a lump sum of $6,000 in 5 years. What amount deposited today at 3.1%, right, compounded annually will grow in 5 years? I think you can do that, right? So we use the same formula, guys, just the different is over here. So Becky must pay a lump sum of $6,000 in 5 years. So the value of A is 6,000. So the value of A is 6,000. After how many years? After in 5 years. So T is 5 here, right? And what amount deposited today? So P equal to what? You need to find the value of P. What amount deposited today? I did 3.1%. So this is 3.1%. So that means 0.031, right? 0.03. Compounded annually. So compounded annually, what will be the value of N? If you compound it annually, what will be the value of n? It will be 1. Right? Compounded annually means the value of n is 1. Yeah, you just plug it in the formula, guys, and get the value of p. So what? So, what is the value of A? 6,000, right? Yeah, the value of A is 6,000. 6,000. And you need to find the value of P, 1 plus, what is the value of R? 0.031 over compounded annually. So this is just 1, you know. And the compounded annually after 5 years. So 5 times 1 is simply what? 5. Right? So now it's going to be 6,000 equals to P. So this is 1.031 raised to the power what? 5. So you divide both sides. Make sense? You divide both sides by 1.031 raised to the power 5. You divide here, and you divide here 1.031 raised to the power 5. You cross them out and cross them out. So now P equals to 6,000 over 1.031 raised to the power 5. And you use calculator, okay, to compute this value, to evaluate this, okay? So now you have 6,000 divided by 1.031 raised to the power 5. So, did I make sense here? And t equal after 5 years, right? Yeah. So I got P equals to 5150, $5,150, $60. Is that right? Does that make sense? 0.031, right? Yeah. Did you get it? Okay. So, if only 5,000 is available to deposit now, what annual interest is necessary for the money to increase to 6,000 in 5 years? So, you need to find the value of R. P is 5,000. You need to find the value of R. A is 6,000. And T is what? 5. So I think you can do this, right? You can do this, guys. Okay, here. So now continuous compounding. So this is the formula for the continuous compounding. So you can see here, okay, the continuous compounding. If the P dollars are deposited, right, at a rate of interest R compounded continuously for T years, then the compound amount A in dollars on deposit is given by this formula, A equal to P E raised to the power RT. Okay? Make sense, guys? So that's for the continuous compounding. Okay, A equal to P E to the power RT. So E is the exponential number, okay? So this is the formula. A equals this future value, this is present value, e to the power RT, where E equal to, I think, 2.71828, something like that, you know. This is the number. And in your calculator, you have a E, okay, tab. You have a key that has E in your calculator. I think so, right? Did you get it? Yeah. Okay, so now let's do this problem, guys. Let's do this. Can you read this? Suppose $5,000 is deposited in an account paying 3% interest compounded continuously for 5 years. Find the total amount on deposit at the end of 5 years. So you find the total amount on deposit at the end of 5 years. Okay? So how much money you are going to deposit? So P equal to $5,000. Okay? And the rate of interest is 3%, so 0.03. Compounded continuously. Compounded continuously. Compounded continuously. So find the total amount on deposit at the end of 5 years. So the T equal to what? 5 years. So the formula is A equal to P E raised to the power RT. Right? So you plug in the value of P, R, and T. So the P is 5,000. E, R is 0.03 times T is 5, okay? Yeah. So this is 5,000 times e to the power. What is 0.03 times 5? 0.03 times 5. So that will be 0.15, right? So 0.15. So what is this number, guys? Can you evaluate this? 5,000 times e to the power 0.15. 5,000 times e to the power 0.15, right? What did you get? What did you get, guys? So this is 5809.17. Yeah. Good? Did you get it? Simple, right? Yeah. Yep, 5809.17. I think we did that one, right? So now the next one is exponential function, guys. No, sorry, logarithmic function. Okay. So remember, we define the exponential function, right? We define the exponential function. Remember, like, we define the exponential function if a is positive and a is not equal to 1, then fx equal to a to the power x. So this is an exponential function, right? Right? So now, we want to find the inverse of the exponential function, okay? So remember, to find inverse of the function, you switch, you interchange x and y. So you interchange this yi, the x, so just like, let me write down here. So this is exponential function, okay? And you interchange x and y. If you interchange x and y, it will be x equals to a to the power what? Y. Right? So if you interchange x and y, you get x equals to a to the power y. Did you say that? X equal to a to the power y. So now, so y is the exponent to which a must be raised in order to obtain x. So that exponent's y is called logarithm. Okay? So you see what I'm talking, right? You see, a is raised to the exponent y. You see, a is raised to the exponent y to get x. So this y is called logarithm. Okay? And it's a symbol, like y is called logarithm. So symbol is log, log. And this is the logarithm with base a of x. So you read as logarithm of x with base a, or base a of logarithm of x, base a logarithm of x. It's up to you. So you can read as, I think like I read as logarithm of x with base a. Logarithm of x with base a. Okay. So now this is equivalent. Now you see these two are equivalent. X equal to a to the power y and y equal to logarithm with base a of x. So they are equivalent. Okay. So what I'm saying here is y equal to logarithm with base a of x is equivalent to x equals to a to the power y. So this is very, very important relation. Okay. So y equal to logarithm with base a of x is equivalent with x equal to a to the power y. So you find one leaf. Equivalent means you find one leaf, okay? So you see what I'm talking, right? This is y equal to logarithm with base a of x is, if I find one leaf, you know, if and only if x equals to a to the power y. And here, you remember a is not equal to 1 and a is positive. You remember that, okay? Okay? Good? So now you see, if you have a logarithm with, let's say, you know, x equal to 8, if you have a 2 to the power 3 equal to 8, you know that, right? So this is equivalent. It is equivalent with, so 3 equals to what? Logarithm with base 2 of 8. So this is equivalent, you know. Because this is now, you can write here, let's say, let me write here, I'm not getting confused. So 8 equal to 2 to the power 3. 4 equal to 2 to the power 2. You know that, right? So this is equivalent. I'm using this relation. 4 equal to 2 to the power 2 is equivalent with 2 equal to, excuse, 2 equals to logarithm with base 2 of 4. Okay. You got it? If you have a 1 equals to 3 to the 3 over 4 to the power 0, so look here, x is 1, a is 3 to the power 3 over 4, and y is 0. Y is 0. So now y is 0. 0 equals to logarithm with a is 3 over 4, and the x is what 1? Log 1 is always 0. Log 1 is always 0. Okay. Now you need to solve this equation, okay? So this is a logarithmic equation, right? Okay. So now how do you solve logarithm with base x 8 over 27 equal to 3? Logarithm with base x 8 over 27 equal to 3. So we use this. Remember, logarithm with base a of x equal to y, this is equivalent, this is true if and only if x equals to a to the power y. This is very important, okay? Right? So now what you have here is you have logarithm with base x 8 over 27 equal to 3. So this is equivalent with, what is your x? Sorry, yeah, what do you, in place of x, we look here guys. In place of x, you have 8 over 27. So write down 8 over 27 here. Equals to, in place of a, you have x. So write down x. In place of y, you have 3. So x cubed equal to that. Make sense? So now you have x cubed equal to 8 over 27. So what is the value of x? If x cubed equal to 8 over 27, then x equal to cube root of what? 8 over 27, which is 2 over 3. So the solution to this equation is 2 over 3. This. Did you get it? X equal to 2 over 3. Okay. Same thing here. If you want to solve logarithm with base 4 of x equal to what? 5 over 2, right? So this is equivalent with x equal to what? So 4. So remember this, okay? If you have a logarithm with base a of x equal to y, then x equal to a to the power y. So this is equal to x equal to 4 to the power what? 5 over 2. That makes sense? So now this is x equal to 2 square raised to the power 5 over 2. So this 2 to the power 5 equal to what? 32? Is that right? Huh? X equal to 32. Did you see that? Yes? So logarithm with base a of x equal to y is equivalent to x equal to a to the power y. Did you get it? Okay guys, I would like to stop here, okay? I'll see you next time. Bye.